afternoon, everybody. I'm here today to talk about some word problems that deal with exponential growth and decay, and using logarithms to help me find or solve for the missing value in the problem. All right, let's take a look at a couple of ideas here. The first one is something called half-life. I've talked to you a little bit about half-life in class, and now I'm going to talk about this actual example where we use the half-life. It says the radioactive yet very handsome substance congonite 40 has a half-life of 500 years. There are 98 kilograms present in 2010. How much will be left in 2210? Well, here's what you got to know. In nature, things decay continuously. Well, since they decay continuously, we use the continuous growth and decay formula, A equals P times e to the RT. Now, we've already defined what these variables are in an earlier lesson, so we don't need to go into that. Now, in this problem, the first thing I need to figure out is how fast is this item decaying? Well, that how fast that I'm referring to is the rate. I need to find the rate of decay, right? Well, because of this, I'm going to use basic algebra ideas, and that is this. In this problem, I have, let's count them together, 1, 2, 3. I have 4 different variables in this equation. For me to solve for this R value, I must be able to plug in for the 3 out of the 4 variables. Don't forget that E is not a variable. It's at 2.7, yada, yada, yada. So that's not a variable. So somehow I need to be able to plug in for 4 of the variables so that I can, or 3 out of the 4 variables so that I can solve for R. Well, the idea of half-life, as we know, it's how many years or how long it takes to go from a full amount to a half of amount. Well, because of that, if I want to find the rate of decay, I know that if, and again, this is just one way of doing it, if I started with 98 kilograms, in 500 years, I would be left with 49 kilograms. Well, if you take a look at this, wouldn't I be able to solve for R now? If I solve for R, that'll tell me what my rate of decay is. Well, if I divide the 98 across to isolate my exponential function expression, I get a half equals e to the 500 R power. Now again, I isolated this exponential so that I could rearrange it in log form. I rewrite this in log form by saying the natural log of a half. Think about how I got that. Equals 500R. Now, to solve for R, I just divide both sides by 500, and so I get the ln of a half over 500 is my rate of decay. Now, I'm going to go ahead and type this in on my calculator. Everybody, I bring my calculator over a little bit. Let me slide them over so you guys can see the screen there. I'm going to type in ln of a half, or 0.5, since we're doing word problems, that's fine, and then divide that by 500. When I do, I get my rate of decay to be this value right here, okay? So I get R equaling this amount right here. So R equals that decimal, okay? Well, now that I know how fast this is decaying, later on it says, well, how much is going to be left in the year 2210? Well, since I know how fast it's decaying, and I know how long it's decaying for, I should be able to find out how much is left of that 98 kilogram mass that I started with. Well, A is the amount that's going to be left over time. So I'm looking for that in this case. A will equal 98 times e to this R value that I have right here, the negative 0.001386, yada, 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 times, well, from 2010 to 2210 is 200 years. So now, if I want to find out how much is going to be left in 200 years from now, I just type in 98 times e to the, well, I'm going to insert that R value there that I got, times 200. I can't get to the 200. Wait. Whew, I found the 200 button. Okay, now hit enter. and I get 74.27. So my final amount is I must have, after 200 years, 74.27 kilograms left. Okay? And that'll be left. And that kind of makes sense. If you think about it, if half of the 98 kilograms would be left in 500 years, well, 200 years isn't, that's not 500 years, so there should be more than half left, and 74.27 is definitely more than half of 98. All right, let's take a look at one more example. This one deals with money. This one says you invest $5,000 into an account paying 2.5% APR, that's annual percentage rate, compounded monthly. How many years will he need to keep the money in the bank for him to have a total of $7,000? Well, in this problem, we have to use the periodic compound interest formula. Now, let's recall that that's A equals P parentheses 1 plus R over N to the NT power. And again, basic algebra says I have 1, 2, 3, 4, 5 different variables I need to be able to plug in for 4 out of those 5 to solve this problem. Well, let's see here. I know that I want to have $7,000 at the end of this time, so that goes in for A. I know that I started with 5,000, that must go in for P. I know that the number of times it's compounded is 12 times a year since it's monthly, so 12 would go here and here. And I know the rate at which I'm earning money is 2.5%, so 0.025 would go here. And lo and behold, I only have the variable of t left to solve for. Now again, since that t is in an exponent, I know eventually I'm going to have to use logarithms. Great. All right, so let's fill in this formula and make it look a little bit more appetizing. I get 7,000 equals 5,000, parenthesis, 1 plus 0.0205 over 12 to the 12t power. I'm going to solve for t now. Now, before I do that, I'm going to have to do a little bit of math here. I have to do, well, I need to condense this into one single base, all right? So simplifying that, I'm going to get 1 plus 0.025 let's see, divided by 12. That decimal comes out to be that, okay? So this becomes 1.00, well, let me just set this over here. So it becomes 1.00208333 to the 12t power, and that's 5,000 equals 7,000. Okay, guys. So now again, I'm trying to solve for this this exponent t. So that means I've got to isolate my exponential. My exponential expression is that. So I need to get rid of the 5,000 by dividing both sides by 5,000. When you divide both sides by 5,000, does it make sense how I get 7/5 equals this long decimal 1.00208333 raised to the 12t power? All right, now that I've isolated the exponential, now I'm going to rewrite this in log form. It would say log base 1.00208333 of 7/5 equals 12t. To solve for t, I just divide by 12, and I get t equals that log divided by 12. On my calculator, let's see how I can type this in. All right, I'm going to go, let's see here. I've got a log button on my calculator, so I'm going to go math up to the second log choice, hit enter. Now, for this base, didn't I want to use this decimal right there? So I'm going to go up there, highlight it, hit enter, and that'll insert it for me. Of the fraction 7/5, right? And then I'm going to take that answer and divide that by 12. And that'll give me the number of years. So according to this, it would take approximately 13.47 years to amass $7,000. Okay? So in about 13 years and 6 months, I would get the $7,000. Okay, folks, that's it for word problems with exponentials. We'll talk more about this worksheet in class tomorrow.